Our speaker today is Engineer T.S. Abdul Malik Hussein bin Abdul Jalil. Okay, and the topic for today is condition-based monitoring CBM versus artificial intelligence AI, characteristic in marine application from an operator's point of view. Okay, BM approved for the CPT is 2 hours, and it's organized by Marine Engineering, Naval Architecture and Technical Division. Okay, my name is Mazhar Suraya Brahmaji. I'm the so-called part of the panels of moderator for this evening talk. Okay, let me introduce a little bit about the speakers. Okay, Engineer T.S. has a whole master in mechanical engineering from UITM, Shah Alam, and graduated also with second class upper honors bachelor in mechanical engineering from University of Sunderland, UK. He also a trained mariner. Abdul Malik also completed the second class certificate of computer system from Malaysia Maritime Academy Alam and diploma in marine engineering from Ukuma Polytechnic, Perak. Abdul Malik carries a wealth of experiences in various aspects of mechanical engineering and design. After his sailing career with MIC for engineer on board SS Tenaga Fleet, Abdul Malik worked as a computer-aided engineer CAE for 4 years at Cape Mark Strandbad, mainly carrying out aircraft-related assignments, mainly engineering simulation, before moving to JP Kenny Wood Group Strandbad, now known as Wood, as a pipeline design engineer for 1 year. Also, for 1 year, Abdul Malik acted as a project manager with SP Energy Strandbad, managing the maintenance of gas generators. Gas generators before moving to edX Strandbad as a technical manager supporting MSC software simulation software solutions such as Patra, Nastran, Adams, etc. Okay. Since 2014, Abdul Malik was welcomed as senior engineering consultant with Cape Mark Strandbad, managing various assignments to various industries related to CBM activities and engineering simulations. One of the significant roles was to be part of the simulation team for the RMF Sukhoi Life Extension Program. Abdul Malik has 10 years of experience of CBM-related activities with Cape Mark. Besides career growth, Abdul Malik has also shown interest in self-professional development. He has been a professional engineer, PEPC mechanical since 2007 and a corporate member of IEM since 2008, and currently is the chairman of IEM's MATD. Also recognized as a chartered engineer with the UK Engineering Council and chartered marine engineer from Institute of Marine Engineering Science and Technology, Emirates, UK. In 2019, Abdul Malik was recognized as professional technologist, TS, in the field of maritime technology, MI, from the Malaysian Board of Technologists, or MBOT. Outside the office, Abdul Malik is currently active committee member of the RINA Emirates Malaysia Joint Branch and assessor and assistant coordinator for the professional review interview PRI process on behalf of Emirates and UK Engineering Council. Okay, that's a little bit introduction about our speaker today, Engineer T.S. Abdul Malik Hussein. And then, okay, today the synopsis, a little bit on synopsis. Basically, in this era of IR 4.0, we are observing a significant shift in the dependence of IT-based solution in our everyday routines, from online banking transaction or to just simply relaxing at home after a hard day work, listening to music on Spotify or watching Netflix. It's no different in the marine industry. Onboard vessels, for example, bridges and control rooms are more sophisticated in managing the everyday voyages. Complex machineries are started using the click of mouse instead of the traditional push buttons. What are CBM and AI technologies? What their definitions and characteristics? How would this impact the operator's decision in maintenance, operation, and planning? Can AI or CBM help the operator in saving long-term costs, and if so, how? The speaker hopes to address these factors in a holistic manner by making comparisons, stating the advantages and disadvantages between the two without prejudice. Okay, providing more questions rather than answer, which solution is better, the choice is yours. Okay, that's all about synopsis about this evening talk. I think without further ado, I think Engineer Malik, you can start your talk. Okay, thank you.
Thank you, Ms. Mazia. Thank you very much. Can you hear me loud and clear?
Yes.
Yes, we can hear you.
Can you hear me? Yeah, okay. So I'll go to my slides. Okay, just a second. Okay, can you see my slide? Mazia, can you see my
see
slide?
your slide. Yes.
Yeah, okay.
Yes, we can see your slide.
Okay, thank you very much, moderator Ms. Mazia. Okay, Assalamualaikum and good afternoon, everybody. I'd like to welcome everyone to my talk. Sharing of knowledge is more sharing of knowledge actually. This afternoon, yeah, it was raining in the morning in Shah Alam, so it's kind of cloudy now. So it's like I'd like to welcome everybody to the title of sharing of knowledge today. Condition-based monitoring, CBM versus artificial intelligence characteristics in marine applications from an operator's point of view. So organized by the Marine Engineering and Naval Architecture Technical Division, IEM, where I'm the current chairman at the moment. So this is more on knowledge sharing. So I hope to just give you a brief overview of what to expect if you intend to implement CBM or AI in your organization. Nothing too fancy. So I hope this will be a two-way sharing of knowledge. Yeah. So although we can't be interactive, yeah, but later in the Q&A session, I welcome all kinds of views, your views and opinions and questions, of course, and I'll try to answer them. Okay, let's move on. Okay, so just a little brief. Just now Mazia has mentioned a little bit about myself. So you're wondering who is this joker trying to talk about CBM and AI at the same time, right? So basically, I just give you a brief about the speaker. So I hold an MSc in Mechanical Engineering from UiTM Shah Alam, Bachelor of Engineering, Mechanical Engineering from University of Sunderland, UK, second class Certificate of Competency STEAM. But of course, my COC has expired. I probably get seasick now if I sail. I haven't sailed in a long time. Diploma in Marine Engineering from Umpoma Polytechnic. In terms of recognitions and certifications, I hold a PEPC in mechanical from BEM, TIS in MI Maritime Technology from MBOD, Chartered Engineer in UK Engineering Council, Chartered Marine Engineer from Institute of Marine Engineering Science and Technology UK, or most popular known as IMARES UK. I have over 10 years of experience doing bits and pieces where my current job scope is IT-based. When I talk about IT-based activities, is related to engineering simulations. And I do have an idea of what CBM is directly to my work. Have I used AI before? No, the answer is no. But over the years, I've been exposed to AI kind of characteristics. So I have a good idea about how AI works and how, if you want to implement it in your organization. So basically, the idea today is for me to share the characteristics of what to expect, and hopefully I don't put you to sleep. It's all about diagrams and flowcharts and theories and stuff like that. So please stay awake with me. Okay, thank you. I move on. Okay. So just brief about the title. So condition-based monitoring, straightforward, artificial intelligence, straightforward characteristics in marine applications. I zoom in into marine applications. And from an operator's point of view, why do I mention operator's point of view? Is because I'm not familiar with the development process, the software development process. So later in the Q&A, I hope I won't get questions such as what platform can this be developed on, what kind of language, and so forth. So we are interested in implementing these solutions, and what to expect, what are the characteristics to expect if you do decide to implement this in your organization. Okay, thank you. So I will move on. Okay, let's look at today's agenda. So agenda CBM, introduction to CBM. Yeah, I will give you an introduction, definition of what is condition-based monitoring, and the monitoring framework. Okay, and expected features of a monitoring tool. Well, what can you expect? Because there's plenty of solutions in the market. So what can you expect if you want to implement such a feature in your organization? So I'll move on. Monitoring for vessels. What is it that we're looking for when we monitor for vessels? CBM development process. What are the steps that you want to take if you want to develop CBM? You see, when we want to implement CBM monitoring, we want to achieve a purpose. Why do we want to basically implement a monitoring system, a stringent monitoring system? Is because we want to achieve something. Yeah, in this case, there'll be a lot of terms I'll be using, such as CBM. Could be, in this case, it's monitoring, but what we want to achieve is conditional-based maintenance. You also hear terms like RCM, reliability-centered maintenance. You also hear terms like FTA, fault-tree analysis. You also hear like FMEA. They're all interrelated. They don't run away. Yeah. So I will jump, but in the end, we'll stay focused to actually CBM, which is condition-based monitoring. Okay, so basically, what are the constraints and limitations, and the benefits of a CBM tool as a monitoring system? Okay, once I've done with CBM, we will go into AI. I hope if I don't take too long, I have 70 over slides. Yeah, so I should be just over an hour or so. Yeah, and okay, so let's look at AI. I'll give an introduction to AI, a little bit of history of AI, and what is the definition? Yeah, AI monitoring framework, expected features of a monitoring tool, and then monitoring for vessels. What kind of features we can expect if you want to implement an AI tool? Yeah, AI development process. How do we want to implement this? Yeah, constraints and limitations, and benefit of an AI tool as a monitoring system. What are the benefits that we can expect to obtain if you want to implement this in your organization? Okay, let's look at the comparison. So now, once my aim is to help you understand the CBM implementation, help you understand what it takes to implement the AI implementation, and after that, we go to the common framework. What is required for CBM and AI? What are the differences? You know, there are differences between CBM and AI. Okay, the common constraint and limitation, the common benefits. We look at the common benefits. We look at and finally the conclusion. Yeah. Okay, I'm going to move on. Okay, now before we begin, I like to ponder. I like to do a little bit of reflection, yeah, in history before I begin. This one I just Googled it. I just Googled this, and as you can see, the link is there. And what is it that when talking about major accidents in history, could this be prevented by understanding the limits of the operational assets? You know, these accidents go way back, yeah, way back to early 1900s. You know, where such technologies at that time were not there, not available back then. But these accidents combine human error with equipment and structural failure. Yeah. So where loss of lives were definitely exhibited. So today in operational environment, yeah, safety is how do you say? Safety is taken into the highest consideration before we want to do anything. Yeah. But still, accidents do happen. So a question, a thought to ponder: could we improve ourselves, you know, by implementing CBI and AI technologies? If you want to, is it a step of improvement or is it a step backward? So that is a question that I portray, and well, the answer is yours. Okay, thank you very much. I'll move on. Yeah. Okay, now as the introduction, suddenly I'm talking about a house. No, I'm not going to civil engineering. Please don't get me wrong. But building a 3-story house, yeah, requires foundation. Okay, let me get my pointer. Hold on. Pointer options. Okay, so building a 3-story house requires the foundation. Yeah, we require a strong foundation, and then the ground floor, we take it as the ground. Then we have the first floor, we have the second floor, and we have the third floor. How does this relate? I will conclude this in my talk. How does this relate to CBM and AI? Yeah, I'll conclude this in my talk later. Okay, let's move on. Okay, let's look at what is CBM, the definition of CBM. CBM is a set of monitoring actions based on real-time or near real-time assessment of equipment condition which is obtained from embedded sensors and all external or external tests and measurements taken by portable equipment. So what does this mean? That means it's monitoring action. Okay, we are monitoring, we're stringently monitoring. For CBM, it can be real time, because we are talking about real time, you need to transmit the data and so forth. But it can be near real time. If you don't have the means, you know, the data could be transferred via portable disk or etc. And that is from sensors. But if you don't have sensors, you can use external tests. You can use your log sheet. You can use your vibration, temperature, measurement equipment. Yeah, so that's what it's trying to say for CBM. What is the purpose of CBM? Okay, the purpose of CBM strategy is to perform maintenance only when there's objective of need, while ensuring safety, equipment reliability, and reduction of total ownership costs. So basically, we want to achieve conditional-based maintenance. So in order to achieve conditional-based maintenance, please excuse me, my throat is a bit itchy. Okay, in order to achieve CBM, you need, CBM in this case is maintenance. We need a monitoring tool. There's no two ways about it. You need to stringently monitor the performance of your asset. You need to record. You need to have a historical database. You need to have means of viewing the performance of your assets before you can make a decision whether you need to perform maintenance or not. So that is what it means here. There is an objective evidence of needs. Yeah. Okay. I move on. Okay, now let's look at CBM per se. Yeah, now when I look at this slide, it has its configuration, usage, health, events, and reliability all together in this. What is this? I will explain later. So CBM is a process where maintenance is optimized through the collection and analysis of data relating to equipment conditions. So you must understand, collection and analysis. Most software in the market today does collection and storage. No two ways about that. But there are softwares out there who do analysis as well. So you have to combine collection and analysis of data, equipment condition, to configuration, usage, health, events, and reliability. So if you look at this, yeah, this is your asset. Yeah, you either collect manual or data recorder, whichever there is available to you. Then you collect all the information, you put it in a CBM system. Yeah, and then then there's the maintenance requirements, maintenance configuration, maintenance log, and it links to your logistics support system. This is very important in your planning. Yeah, why it links to the logistics support system, I will explain it later as well. Okay, I'll move on. Okay, let's look at the CBM data model. Yeah, so you have usage monitoring, produce usage data, configuration. What is configuration? I will explain later. You have health monitoring, health data, significant events monitoring, fault detect monitoring, and it all relates to maintenance effectiveness analysis. Yeah, we schedule maintenance. You can't run away from it. It's already recommended by the OEM, especially if your equipment is under warranty. You have to do your schedule maintenance on time, or warranty is void. Yeah, corrective maintenance. Yes, when the equipment breaks down, you have to do corrective maintenance. You can't run away from that also as well. But now to achieve conditional maintenance, that is what the whole idea is about, to implement a CBM system. Okay. Okay, I'll move on. Okay, if I look at this flow chart, it's quite interesting actually, because it starts off with engineering analysis. Yeah, if you look at this equipment, it starts off with engineering analysis, and then it goes down, flows down to diagnosis, predictive maintenance recommendation. So again, I would like to emphasize that we want to achieve a status of conditional maintenance. So without any stringent monitoring tool, without any data, you can't do that. Yeah, you can't tell when is your equipment going to fail. You can't tell how is the performance of your equipment on certain conditions. So let's look at the engineering analysis part. Yeah, you have the data capture criteria. How are you going to capture your data? Algorithms and formulas. What does it mean? That means there is a relationship between the performance of your equipment, yeah, in relation to the failure of your equipment. So there is formulas. You know, I'm not a rotating equipment expert, yeah, but if you look at the rotating equipment, there are formulas that represents the life of the equipment. Yeah. So how do you translate that to monitoring your asset? So all that can be implemented. Then the condition indication history, the baseline limits. So baseline limits is usually given by OEM. Yeah, OEM will have. I remember when I was sailing the last time, there are certain limits where you can't run the speed of the turbine because the whole engine room will vibrate. Yeah, so how do we know these limits? These limits are all given during the design stage. So we do have the design data is available. The performance of your pump, the performance of your motor, the limits, the upper limits and lower limits are given. Okay, and of course knowledge base. When we talk about knowledge base, OEM document, OEM stands for original equipment manufacturer. When they design the thing, when they design the equipment, they will have how do you say, the troubleshooting. Supposing when this goes wrong, what will happen? When this goes wrong, how do you approach your equipment when something happens? Okay, you have all that in the document. That is one way. Another way, of course, is by experience. That is very rich. Imagine if you've been operating for 20, 30 years. Yeah, your plant has been operating for 20, 30 years, and you have all the knowledge. But are those knowledge captured and put into a database? So that is the question that we have to ask. Yeah, so we have equipment, we have measurement signals, data acquisition, raw data, condition indicator calculation, condition indicator status trend, and basically what we want to achieve is here. Okay, and of course the data interpretation as well. Okay, I'm going to move on. So if you look at this, sorry, it's all about flow charts. Yeah? CBM process flow, condition-based monitoring process flow. We have the operational data, we have our historical data, we have our maintenance record, and we have to somehow synchronize all this into one database. Yeah, one database and do all the necessary. But what we want to achieve, I'll just summarize this flowchart. As you can see, FTA stands for, this is at the later stage. You know, later stage. Once you have all the data, you want to really understand, then you do the fault tree analysis, or you do your failure mode and effect analysis to produce the risk ranking. But basically what you want to achieve is the operating decision. Yeah? The operating decision, whether your equipment can be operated at a particular time, or is it serviceable, or it needs servicing, etc. Okay, I'll move on. Okay, now in the engine room, when we talk about, I zoom in a little bit on a marine application, you have all this data. Yeah, you have all the vibration data, you have the thermal imaging data, you have your loop oil analysis, you have your maintenance data, you have your noise data. Certain places you want to make sure that it's quiet, no noise, and then you know, how is this data being put inside? How is this data collected? Do you scan them? Is it direct entry, or is it using hard drive or pen drive? And what is the data that you're looking at? So all this goes into basically a monitoring tool database. Yeah. So I'll explain more as we go along. Okay. Okay. Now, if you look at this, this is a market survey carried out on CBM in relation to monitoring. If you can see in the APAC region is growing. It's a huge market share. So it's up to 3.9 billion in 2025, which is 2 years from now. The prediction is in 2009. The study was done in 2019. So it's actually a huge market for CBM in relation to monitoring. Okay, now once you have all you understand the fundamentals now. What the fundamentals say is you need data. Yeah, that is the fundamentals. You need to translate and you need to store operational data. So how do we do that? Okay, so we look at I jump a little bit. Yeah, I jump a little bit from the monitoring framework. I jump into types of maintenance. Yeah, of course we have planned maintenance. Yeah, planned maintenance is something I explained just now. We have corrective maintenance. Yeah, and we have condition-based maintenance. If you are able to achieve all these three aspects in your organization, yeah, we are looking at a reliability-centered maintenance status. That means you are able to see your equipment individually. Is it reliable? Is it performing at that particular time? You know, at that particular time, how long will it take to fail? You will have all that data. Why do we need the data? Because you want to know the health condition of your equipment or your plant. Okay, I'll move on. Okay, let's look at condition-based monitoring. What are the criteria? What are the characteristics of condition-based monitoring? What is it? Oops, sorry, I went too fast. Okay, never mind. I went to the next slide. Hold on. Okay, what are the characteristics? Okay, let's look at this. We are looking at missionary diagnostic behavior. What is missionary diagnostic behavior? Missionary diagnostic behavior is behavior patterns that includes comparison of current and past conditions. So the richness, okay, the richness of when you do condition-based monitoring, the how do you say, how rich you are is based on how much of historical data operations that you have. That means, or you say you have 5 years of operation data, you have 10 years, but you have to start somewhere. Yeah, you have to start. Supposing you haven't collected the past 10 years and now you're starting to collect, it's okay, you start at a particular point. But how rich is your CBM capability will be depending on how much data, historical data that you have accounted, that you have stored. Yeah, you have stored. It's okay. It doesn't mean that you have to have a database for it. You just store it somewhere. Probably it's in a log sheet, or probably it's in a thumb drive somewhere. It's okay. But now you need to centralize that data. Okay. What is next? Next is parametric trending analysis. So what is parametric trending analysis? External factors that influence specific trend. So when you look at parametric trending, you want to see, okay, supposing you see the performance of a main engine, yeah, you see, then suddenly you see some irregularities. Then you do some basic maintenance. For example, you do a loop oil change, and then you can observe back again. How is that? How is the trend of your machine? So all that can be monitored in a CBM system. Yeah. What's next? Next, we look at troubleshooting. Troubleshooting is very important because troubleshooting is able you to how do you say to approach a particular problem more significantly. Yeah, so we have, as per OEM document, like I mentioned earlier, we have OEM documents has given you guidelines, yeah, on how to approach certain problems, and of course your experience as well. I'm sure in the room I have many people with a lot of experience at sea, a lot of experience managing. Have you documented your experience? Lesson learned. Yeah, imagine if you have all this in a centralized database and we're able to extract that when needed. That can help you to develop a more efficient condition-based monitoring system. Okay. Let me move on. Okay, let's look at this. Let's look at an example of a monitoring tool framework. Imagine this is your operational, this is your asset operating. Yeah. So you look at this. You are extracting data, operational data, to a portable ground station because it depends. Like earlier, what I mentioned is that. Data can be collected in many ways for CBM. Yeah, it doesn't have to be only sensors, it can be manual, but it depends on how frequent you do it. Because the CBM is based on human judgment, it's based on your experience. But you need the data to be displayed for you to be able to make that sound judgment or sound decision. So as you can see, the operational data goes to a portable ground station. Where this portable ground station will translate the data and goes into a general database. Believe me, this is just a framework, example of a framework. Yeah? Okay, so in this general database, you store all your data, and from here you segregate your data. Which one do you need for your structured database? Yeah, which of this operational data affects your structure? You know, makes your crack go bigger if you have any cracks. You know, which of this data is for your troubleshooting database? Which of this data goes to your maintenance database? Can this be done? The answer is yes, it can be done. Yeah. So from here, from this huge database that you have here, then you start to report one by one. You will report your fleet reporter, your maintenance manager, your component life limit, your shop visit and scenario planning, and then you can use it for early failure detection. Yeah, once you have a very rich database like this, you are able to manage your maintenance more efficient. Yeah. Okay. So what sort of data? So just now I mentioned about a monitoring framework. So what sort of data that can be expected from a monitoring tool? So now we look at the characteristics. Okay. Okay. Now every part has a serial number. Yeah, if you're buying a part that has no serial number, maybe it's a chipla part lah. But every part has a serial number. So imagine that you have a system or a CBM system that is able to monitor these parts. But believe me, this is what we mean by configuration management. That means you have a whole system on its own, and then you're able to break down the parts. Sorry, I have to blacken out this certain areas here because it is confidential information. I screenshot from a live software. So okay, so the system, you are able to track, but make sure whenever you do your configuration breakdown that you are able to track lah. Say for example, just say for a pump motor, what is it that you're monitoring in the motor? You're monitoring temperature, you're monitoring vibration. Then you're able to break down the pump into smaller units, but you are able to track the parameters that is affecting the performance of the component. Yeah. So if you look here, configuration tracking. Yeah. So I have an example here where the left engine is being stripped down. Sorry, this is for an aircraft, not marine related. So this is just imagine if it's marine, then you have your main engine, you have your piston, you have blah blah blah. But you are able to track all this. And is it tracked to running hours? Is it tracked to vibration? Is it tracked to temperature? Is it tracked? So it depends on what kind of information is available in your plant. How is it monitored? Yeah. Okay. So this is configuration tracking. Okay. So now this is event analysis. You have all the database, like I mentioned earlier. You put everything into a general database, and you're able to extract the data. Yeah, the event analysis is also part of trending. Yeah, so I'll move on. Okay, you're able to see equipment failure pattern. Imagine the database, the performance that I mentioned to you just now. Say, for example, a seawater pump. You're monitoring the suction and discharge pressure. As time goes out, supposing you're monitoring discharge pressure, you have data on the discharge pressure. You take logs every day or every few hours. You take logs. And you have data to show that after a certain time, after a certain period of time, probably the pressure the pressure goes down, or you find that the vibration goes high, or the bearings become hot, or something. There must be a measurable parameter for you to track. Yeah. Okay. So now I move on. So basically, this is just an example. Yeah, first line troubleshooting system. So you have that database, and you are able to extract data to show from the trending analysis. You are able to extract data to show that your limits. Yeah. So it is for example. The limits of class of equipment, left engine, limits of part type, limits of particular heart reader. Where do we get the limits? We get the limits from the OEM document, the design document, or from your experience. Over 20 years of maintaining a plant, you will know the limits of your plant. You will know the limits of your equipment. So all that can be tabulated into your CBM system. Health monitoring. This is just an example of health monitoring. So you know your engine status, your code. You can show in the system yellow is approaching to danger, red is already danger. All that can be shown. Yeah. Okay, logistic support tools. Now, we have already, once you have a stringent monitoring system in place and you're able to achieve CBM, conditional based maintenance status in your organization, you're able to plan your spares more effectively because you have organization, it supports organization level. This is just the characteristics of what to expect. Yeah, you support the organization level, the intermediate level, depot level maintenance planning. Yeah, engine stagger report, shop visit, rate projections, opportunistic maintenance planning, space provision, best building components matching, and all projection reports can be optimized by establishing a window opportunity. Okay, so basically what it's trying to say is that you are able to project your spares. Yeah, so this is just an example, spares projection. Yes, I'm just giving you an example of equipment and the years. How many do you need? How many do you need based on your maintenance planning? Yeah. Okay. So for monitorings of vessels, we have loads of data. Yeah. Where do we want to start? You have your operation data, you have your maintenance data, you have your inspection data, oil analysis. But if you intend to start, you have to start somewhere where it's trackable, somewhere where it's measurable. Then we're able to see the significance of having a CBM tool. Yeah. So one of the easiest to track, I suppose, I could be wrong, but one of the easiest to track it would be the ship operations data because you have sensors, you take logs every day, you monitor the ship voyage hours, you have the vibration, you have the component life limits, engine temperature, up, down time, all this is measurable. So all this can be collected and stored in your database. Yeah, and of course you have your maintenance schedule. Yeah, you have your inspection records, and you have your oil analysis that you do from time to time. All this can be recorded and integrated. Yeah, you can interrelate. You can see when you do your change of oil, you can see how does the change of oil affect the performance of your engine. Does your RPM go for the same speed? Does your RPM engine go higher or lower, or does it maintain the same? All that you can monitor. You can see. So what is it that you hope to achieve? Your general operational requirements, your ship engine fleet management, configuration monitoring, inspection and historical maintenance record, your engine operational health condition status, troubleshooting and trending, the FLTS, first line troubleshooting, and other engineering analysis. Remember, you're not only collecting data, but we are also carrying out analysis as well. Okay, I'll move on. Okay, now you have all this data. I'm just giving you an example of a data storage. You have all this enormous amount of data that you have collected, you need to put it in a central database. And once it's in a central database, you need to track and keep a record, So data storage, what is important is you need audit trail. Yeah, you need to know what is done, who took out what document, what version of document is being put inside. So this is just an example. I'm just giving you an example here. Yeah, so, okay, so I'll move on. Yeah, okay. Now, I've given you an overview of what to expect in characteristics when implementing CBM. Yeah, when we're talking about condition-based monitoring, we're talking about what are the characteristics, what are the how do you say, the functionality of a CBM system, and how can it help you to achieve the conditional-based maintenance status in your organization. So now, how can the CBM status be achieved in your organization with the help of a monitoring tool? CBM in this case is maintenance. Like I mentioned earlier, I'll be jumping from term to term, and when we talk about CBM, some will relate it as maintenance and some will relate it as monitoring. So now, in this question, CBM here is referring to maintenance with the help of monitoring tool. So let's look at the CBM process. System audit. Of course, step one, you have to do audit in your system, in your organization. What kind of data that you can collect. What is it that is important for you? Yeah. What is it? Like I said, different ships have different, ships are very complex systems. There are hundreds of machineries inside, if not thousands of machineries, thousands of systems inside, yeah, components and all that. So what is important? What is critical to be monitored? You can't monitor everything; it's impossible. Yeah, but there are certain equipments, there are certain how do you say? There are certain systems that like to fail, like to break down and fail. So maybe those are the critical and infects the ship's operations. So that can be defined as the critical equipment that you need to do an audit. And can this equipment be tracked? Yeah, what is it that track? Are we checking the running hour? Are we checking the vibration? Are we checking the temperature? What is it that we are tracking? Okay, so that is the idea of system audit. Next is streamline RCM analysis. So, like I mentioned just now, we want to achieve reliability-centered maintenance, RCM. Yeah, to achieve this, we need to, I will show you another flowchart later. We need to streamline this. We need to figure out what is the process flow, what is the, you need to centralize everything so that you know what is it that you want the output to be, what is it that you want. Yeah. Okay, what's step 3? Health indicator development. This is important because every equipment fails differently. So you need to know what is your, how do we develop the health indicator? That means how do we basically select the damage mode, yeah? The damage mode of your equipment. This equipment fails because of this, this equipment fails because of that. So you need to develop the health indicator development. Okay. Okay, information system specification. So this is when we go to the IT part of it, where we develop the system according to the needs of what is required. Okay, and then the CBM system set to work. Okay, basically that is the idea. Yeah. So if we look at RCM analysis flow chart, basically item failure, disaster, yes, no, better let it fail. Yeah, I'm not sure whether in my limited experience at sea also, I'm not sure whether I have any equipment to better let it fail. I don't think so. But condition indicator, get stats on life, better repair and condition, repair and schedule, or repair and condition. So all this is basically an overall flow chart for us to decide on the flow of the maintenance process. Yeah. Okay. Select damage mode. Select damage mode is very important before we develop the procedure. Yeah. Because we want to know, like how I mentioned earlier, we want to know how does that equipment fail. Yeah. How does it affect the operation of the ship? Is it critical? How do we want to rank? We need to rank the importance of that equipment, of that component to that particular system. Okay, to select possible indicators, select sensitivity tests, ambiguity tests. Ambiguity is ways of the equipment can fail, and then statistically behavior tests, and then you develop the procedure. Yeah. Okay, I'm sure all of you heard of the PF curve, the potential failure curve. Yeah. So basically, each equipment will have this. How do we develop this for your? How do we develop the PF curve for your asset? Yeah, it looks like it's rocket science, but actually it's not rocket science. Yeah, it is something based on. That's why I said how to develop an effective CBM system. You need to store the operational data. You need to have a rich history of the operation of your equipment. Easier said than done, but is it doable? Yes, it's doable. Yeah, it can be 1 year, it can be 2 years, it can be 5 years of pattern, and then you're able to produce this curve. It may not be accurate, but at least you'll have an idea, point of where failure starts to occur, potential failure point where we can find out where it's failing, and then finally the failure where it fails to meet the requirement. Yeah. So this all relates to the data that we have. I'm sure you have heard of MTBR, MTBF. We need to record all that. All that is very important. Mean time before repair, mean time before failure. So you'll have an idea of how long does your equipment last. Yeah, that's very important. Okay. Okay, the PF curve can be used. The PF curve to be of any use, it must be consistent. Of course, it needs to be consistent with the data that you take, must be consistent throughout. Yeah, practical to monitor. Like what I mentioned, you need a indicator to monitor running hours. Is it running hours? Are you monitoring vibration? Are you monitoring temperature? Are you monitoring pressure? Are you monitoring what is it that you're monitoring? It must be practical to monitor with a clear indication of potential failure condition, and of course long enough to permit realistic monitoring intervals. Yeah. So basically, not only you have to monitor, you have to have a clear indicator, but you also need a time period to get realistic results. Okay. Okay, what is next? You know, CBM is actually it's not something that is I invented. It's basically used in the Western world since the early 80s. From what I know, Canadian Navy, US Navy has already implemented CBM in the early 80s. Yeah? And what is next? I mean, you're talking about in situ decision. Yeah, you're talking about making decisions on the spot based on the data that you have. Now, if you look at the CBM Plus, now they call it the CBM Plus architecture overview. Yeah, you have on system, you have at system, and you have off system. Yeah, with the help of this one, that means you have a ground station, you have on system, at system, off system, where the ground crew or the ground can analyze your data more efficiently and can give you advice on the spot. Yeah, that means they will analyze your operation data and help you to make better judgment. Okay. Okay. So now let's look at the implementation constraints and limitations. Basically, what stops us from doing this? What stops us from implementing a CBM tool? You know, when we talk about CBM, we talk, oh, it's not necessary. You know, the machinery breakdown, the ship still can move, the ship still can float. Yeah, but you know, what stops us from doing this? So what are the constraints and limitations? Basic parametric trending and monitoring for first-line troubleshooting. So we are talking about limited forecast and prediction. Yeah, so there's no data to support a basic parametric trending and monitoring for troubleshooting. Incomplete data acquisition and collection. That means you don't collect enough data. Your collection is not sufficient. That means you are doing more corrective maintenance than planned maintenance, for example. I'm just giving you an example. If you collect logs, if you monitor, say, for example, the log sheet, if you do it only once a day, how are you going to monitor the performance of your asset? Means don't tell me once a day you collect your log sheet, once a day you do a noon log reading, and that determines the performance of your asset throughout the day. No, I don't know. I don't think so. Yeah, so incomplete data acquisition and collection. Yeah, if you don't want to do it manually, then you have to invest in sensors. You have to put sensors on board so that continuously monitoring the parameters. Yeah, and without data, you cannot do any engineering analysis. Without data, you can't do anything actually. Okay, so lack of technology enabling tools for data repository and analysis. Of course, this is the database I was talking about. Yeah, you may have your operational data stored somewhere in log sheets, printed out and stored in the file. You know, you have your maintenance card, you have your maintenance logbook, you have your everything is stored, but it's not in a central database where you can easily extract. If something happens, if you need information, how do you want? If something happens, you need to do investigation. You know, how are you going to get the data? Yeah, you need to go back, open back your cupboard, open back your file box, open back your maintenance card. It's very tedious and it's very time consuming. So this is what it means, limited MTBR. Okay, so lack of technology, limited mean time before repair, mean time before failure. You need to record that, at least that, so that you know when is the time, how long does it You know, when does your equipment fail? How long does it take? And how long does it take to repair? Or how long does your equipment before it fails? Yeah. Insufficient infrastructure and configuration for CBM. Okay, this one is if you don't have all three above, definitely you won't have infrastructure and configuration for CBM. So you won't be able to do troubleshooting and diagnostic. Yeah. Okay, transformation recommendation. Upgrade infrastructure and system configuration. Okay, you can upgrade or you can improve your process. Doesn't mean you have to spend millions of dollars to put sensors everywhere. Oh, I want to start CBM. I need to put sensors here and there, here and there. No. I mean, it doesn't have to be that. You can work with what you have first. Like I say, you start somewhere. You know, work what you have, improve your processes. Instead of you taking logs once a day, you take log 4 times a day. So you have a certain collection of data. Yeah, and you store this data. If you're using paper, last time you're using paper, now you invest in iPads. Yeah, you invest in tablets where you can digitally record your how do you say? You digitally record your operating parameters, and then you store it in a hard disk, and then you have the database with you. You know, so okay, so enabling tools and data repository improvement. Yeah, this is what I mentioned just now. Enabling tools. We're talking about having a central database, in-depth analysis for maintenance improvement. Okay, this is what I mentioned earlier. The MTBR, MTBF. More compliance with OEM rules. See, when you have all this data, you will be you will operate within the limit because you are aware. You're more aware of the functionality of your plant, the functionality of your equipment. So you will be more compliant with regulations and equipment operational limits and guidelines and maintenance practice. Okay, I'll move on. Yeah, so what are the benefits? What are the benefits that we can hope to achieve? So of course, we want to prevent catastrophic failure. Yeah, that's the first. Imagine if you are able to detect a spike. Say you're doing a trending, you detect a spike. All you got to do is investigate that spike in temperature or the spike in RPM, certain hours. You know, all you got to do is investigate. Is it a sensor problem? Is it a malfunction somewhere? Or is it a wrongly recorded reading? You know, you are able to do an early investigation, yeah, to avoid, to prevent catastrophic failure and avoid accidents, of course, in the long run. Yeah. Extend life limits of components and equipment. You definitely can do this because you understand. Okay, I mean this is a bit on the how do you say, on the shady side, because extend life limit of equipment and components, because you're tracking the usage of your component, you're tracking the usage of your equipment. Your OEM says you have to do this at certain hour, you have to do this. You have to do this after certain running hours, you have to do it. Without warranty, what? Fine. If the equipment is under warranty, what happens if the equipment is under warranty, off warranty? Do we still follow the OEM recommendation? That is another question. That's another question to ask. Yeah. Okay, now provide avenue for health diagnostic. So what, as I mentioned earlier, we provide avenues for health diagnostic, to select damage mode. That means you're able to diagnose your equipment. Provide prognostic early failure detection. Yeah, that's like what I mentioned earlier. Yeah, so you're able to detect failure early. Okay, and performance and historical information. Historical information is very important. Yeah, it's very important because your machine is constantly running, and suddenly you find that the temperature is going up. Suddenly you find that the RPM is not this one. So how would you know what is going to fail next? Imagine if you have this database, you have the historical information, you store it, yeah, and this historical information will determine how rich your CBM system would be. Yeah. Okay. So basically, we want to achieve maintenance improvement and cost optimization. We want to develop an expert system. We want to develop prediction. You want to build cost logistic forecast, maintenance efficiency, manpower effectiveness, and part life tracking. So these are some of the benefits that we hope to achieve. Yeah. Okay, this is some of the publications on CBM that you can find. This is all online. So you can find you can read more about it. There's a lot actually on condition-based monitoring. Yeah, and yeah, okay. So I have touched on CBM. Yeah, the time now is 5:53, 5:50, 5:50. Can we take a 5 minutes break? I'll come back at 4 o'clock. We'll come back again at 4 o'clock. Mazia, are you still there?
Yes.
Hello,
Okay.
Mazia. Yeah.
So, okay.
Yeah. So I will come back at 4 o'clock. Yeah. Take a 5 minutes break. Yeah. Come back at 4 o'clock, and then we'll continue with AI. I don't have much slides more to go. Okay. Come back with AI. Okay. Okay. Thank you.
All right.
I'll off the camera for a while. Okay. 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 Good evening, everybody. Welcome back. Yeah. Okay. So I've already touched on the characteristics of CBM, and what to expect, and what to expect if you want to implement a CBM tool in your organization. So now let's look at AI. So as I mentioned earlier, I have not used AI before, but over the years I've read about it, and I have a good understanding of how it works and how to implement it effectively. Yeah. So let's look at my next slide. Okay. So now some of the following information on artificial intelligence is courtesy of our my friend who's from Bumi Data Mining Sdn Bhd. Yeah. So some of the slides is his properties, and he's big. What is this? Courteous enough to share it with us. So with that, I thank you. Yeah. And okay, let's look at a little bit on history of artificial intelligence. What is AI all about? So AI was the term AI. One of the founders of AI was John McCarthy. Yeah, he lived between 1927 to 2011. Yeah, he coined the term AI, artificial intelligence, in 1955. So he's one of the creators of our longest lived computer languages in the world, LISP. Please don't ask me what is that, because I'm not sure what is that, but it is a computer language. Yeah. Okay, let's move on. Okay, so now artificial intelligence. Hold on, please. Just check my mic is on. Okay. Okay. Artificial intelligence. What is the definition? Yeah? It's a way of one definition I found on the internet. It says a way of making computer, robot, or software think and act like a human. Is that true? Is that what we want? Do we want it to act like a human, or we want it to be more than human? If you want it to think and act like a human, then we can do the job, right? Why do we need to replace? So that is one definition that I found on the internet. Yeah. So another definition that I found on the internet, artificial intelligence is the ability for a computer to think and learn. I like this one better. Yeah. So this one says that AI the computer is able to think and learn and adapt itself, and then provide us a solution that we need. Okay. Now let me move on. Yeah. Okay. Now let's look at this monitoring framework. Yeah, you have all this data. Again, we're talking about data. All this operational data, all this storage data, you store it into a centralized data storage, and then basically it's either standalone in your organization, or you access it to a cloud somewhere. You keep it in a cloud somewhere, and then you have this AI software. Yeah, this AI software will extract it, and then it will generate all these solutions, based on what you want. The real-time failure. So AI, when you talk about AI, it talks about real-time. Yeah, it doesn't talk about near real-time. It doesn't talk about human intervention. It doesn't talk, because it needs a lot of data to learn. Remember the definition, the ability of computer to think and learn. Yeah, so you need a lot of data. So we are talking about sensor data. Yeah, if you are going to give manual data to the AI software, you need loads of data. You need loads of man hours to produce that data for the AI software to be able to learn the behavior of your particular processes. So real-time failure prediction, probable root cause analysis. proven cost reduction, visual dashboard, fully automated, able to integrate data from existing software. Like my friend say, using AI is not a BOMO. You're not a BOMO. You cannot just hold the machine or look and then pop, and then you come up with a solution. It's definitely not like that. There's a lot of work to be done to understand. Is it simpler than CBM? Is it simpler than implementing CBM? Well, that depends on the capability that you have. Yeah. Okay. Now move on. Okay. Let's look at developing framework. Yeah, you have all the processes that is running normally. You need a physical intervention. You definitely need an intervention. Yeah, so you have machine learning, you have insights, you have deep learning, data collection. Yeah, you have the human judgment, scenario analysis. Everything goes into the AI software. So you can actually, like I say, you can actually run the software, have a cup of coffee. 10 minutes later, the solution will give you the answer. Is that true? I mean, that's what they say that using AI software can do, but there's a lot of work to understand the processes that is involved when using an AI software. Yeah, I will move on. Okay, now AI monitoring tool features. I'm taking one example. There are many markets out there, but I'm taking an example from Bumi Data Mining Sdn Bhd. Yeah, so centralized data hub with fully backward and upgrade compatibility, fully automated data ingestion and processing, automated report generation from any analysis. It means you are able to do analysis, lubricant, vibration, visual dashboards. It's mobile ready, digital platform with agility for future digital growth. So real time, we're talking about real time. If CBM talks about real time and near real time and portable equipment, AI emphasizes on real time. AI prediction to failure in hours, days. That means it's able to predict the failure of your equipment, whether your ship can sail or not, within hours, within days. Probable root cause of failure analysis, remote fleet performance tracking and monitoring, process improvement, information for breakdown maintenance, planning and spares management. Yes, you can see, I know from the characteristics that I provide, I'm sure you can by now sense some similarity between CBM and AI. Yeah? Okay, now let me move forward. Okay, so real time, anywhere. Yeah, either use your workstation, use your iPad, use your mobile phone. Can this be achieved with CBM? It's more work, but can it be achieved? Yes, it can. Yeah, also can. Yeah. Okay, so now I will move on. Okay, this is a marine example of a marine vessel system health. What it can do is it is able to predict the health, the risk metric categorizes equipment in real time based on likelihood of failure and impact to production. That means it's able to, it will digest the data that you provide, and then HVAC, electrical, blah blah blah, and so forth, and it's able to predict how long will it last under that current condition. So you can achieve the prediction maintenance status in your organization. So I'll move on. Okay, so this is basically a dashboard overview, visible offshore and offshore. So basically, as you can see, it has a HVAC, is general, tanks, you can monitor all this in real time, provided you can provide data. You have sensors inside, and you're able to provide the data. Yeah. Okay, so this is another example of a dashboard of an AI solution. Yeah, what can you expect of an AI characteristics? You can actually show the condition, the performance of your engine 1, engine 2, and so forth. Yeah. Okay. So individual proportional. Just now we look at the overall. So now we look at the individual engine performance. Yeah, you can actually replicate your control room and shows the performance of your engine. Yeah. Okay. Okay. Now let's look at this slide. If CBM looks at a particular component or particular asset and breaks it down, AI looks at the system holistically. That means it looks at the system full. That means you have you have 5 assets, you have 4 processes. You have process A, process B, process C, and then you have asset A, asset B. So it looks at all processes, broad data field, identifies seemingly unconnected processes and interrelated problems to find contributing factors and root cause. So basically, it will scatter and it will plot all kinds of data. It will digest, it will learn, and it will use statistical formulas, and it will create relationship between all your asset performance to all the processes that's involved. That's my understanding. Okay, so if you look of AI, yeah, you look at the preparation, yeah, organize and supply of historical data, set up streaming and real-time data, then the ingesting. That means it has to learn. You know, the ability of the computer to think and learn, but it needs data first to learn. Okay, and then you have workshop, you have ongoing training and support. So no sensors and installation required. No, like, okay, what it's trying to say is you can use your existing, provided that you can provide the data, that to use the solution, you don't need any additional facility to be installed. Okay, so if you look at how AI works, yeah, existing monitoring sensors from assets or data historian, sensor data, secure communications, data center, it goes to our AI plus data and continue learning, and then you produce the reports that you want. Yeah, the user configurable web UI dashboard. So it's able to produce the report that you want to the on-site personnel and off-site personnel as well. Yeah, this is another representation. So remember, sensor data is raw data. I mean, if you say that you can drink a cup of coffee and then operate the AI, yeah, you know what are you looking at. Yeah, remember, sensor data is all 010101, and you need to know what is this 0101 configuration is reflecting to which equipment, reflecting to which sensor. So you have to know what you're looking at. Yeah, it's not just drinking coffee and expecting the results to come out. Okay. Okay, so I'll move on. Okay, so this is a major case study. Yeah, case study that have been done before. Yeah, where the ability to understand the drop of discharge pressure causes the gas temperature motor to trip. The team was able to increase computer uptime, so they're able to detect a fault in a complex system. Okay, rapid identification of root cause. So relationship, this is what it means by relationship between seemingly unrelated process. That means you won't know. If you look at CBM, CBM tracks assets individually, like how I mentioned earlier, and you need to use your human judgment to make the decision. Yes, based on your experience, based on your response. But this one, the computer will do it for you. Yeah, it will study, it will determine what are the root causes, and it will develop a relationship between, you know, totally unrelated process. Okay, so what are the implementation constraints and limitations? Yeah, so I hope by now you understand that the characteristics of CBM, characteristics of AI. Yeah, and let's look at the implementation constraints and limitations. First, we have data availability. This is very important. Yeah, I mean, CBM talks about data, AI talks about data as well. Yeah, data interpretation. Remember, you're dealing with raw data. Yeah, sensor output is raw data. You have to interpret it. How you want to interpret it? It is usually in the guidelines. It's usually in the manual. Manuals will have this number will represent this sensor, this particular reading, and so forth. Right? Supporting infrastructure to support an AI solution. Yeah, you have to have infrastructure to support AI solution. That means you have to have a place where you store your data. Yeah, a centralized database. Either you have it in-house or you have it in the cloud somewhere where the AI solution is able to extract this data and able to process it and produce the results that you want. Yeah. Supporting documents to support data analysis. Once the results come out, you need to know what are the results that is out. Yeah, so you need supporting documents and initial investments cost. Yeah, this one is also related to CBM as well. Yeah, because whatever it is, everything is about dollar and cents. yeah, you need to invest in certain, you need to have certain initial investment costs to carry out this exercise. Okay, let's look at the benefits. Yeah, again, it talks about increased production. Yeah, it talks about improved asset reliability and life cycle. Yeah, it talks about improved safety. Yeah, you're able to make early detection. You're able to do predictive, how do you say, predictive maintenance, achieve predictive maintenance. So definitely you will improve safety, improve environmental performance. Yeah, decrease decision making time and resources. Yeah, because the computer is making a decision for you. Yeah, and increase profits. And in the long run, you find that you are able to solve a problem that is not yet coming, and you're able to extend the life of the performance of your assets. So now, this is the example of increased profits using AI. So this was a paper presented in SPE 2019. So what is just an example? So because maybe you can't relate when I say it, but this example hopefully can give you a better idea. Constant tripping of gas compressor, yeah, but the frontline technical team could not find the issue. Yeah, operation requirements for this compressor to be fully functional to avoid a USD 1.2 million demurrage penalty. So by using the AI, the technical team is able to predict the time and failure and find out the root cause. So this is where the AI comes to play. Yeah, so you have a problem that the engineers cannot solve. You know, it's too complex. You can't find a relationship between the AI can help. Yeah. Okay, so this is some of the publications on AI. You can read it. You can Google publications on AI, and this is some of the publications that I found. Yeah. Okay, so let's look at the common framework. What is it that is common between CBM and AI characteristics? So we look at data extraction, human intervention, or sensor data. Yeah, infrastructure. You need infrastructure, standalone or cloud. Yeah, this is a common framework. You need a centralized database. You need, for CBM and for AI, you need a centralized database. You need to do data analysis, human or machine learning. You need dashboards. Dashboards is to produce, for you to extract your reports. I mean, dashboards is for you to view, you view your statistics. Yeah, and you need report generation, of course, report generation. Common constraint or limitation. One is mindset. Mindset. Why do we say number one is mindset? Mindset. We need to start somewhere. You know, you can't go business as usual and expect a different result each time. And if you go business as usual and expecting a different result, something is not right. So you need to start somewhere. No CBM, you can start somewhere, or you want to use if your operational plan is a bit advanced, you have the capability to implement AI, then please, start surveying and start looking at it. Limited data availability. That means there's no, you want to do it, you want to track, but you don't have the capability of collecting data. That is a problem as well. Limited infrastructure, that's what I explained. Limited or no data enabling tools, no budget for initial investment. Well, we need to invest, for the long run. Yeah. Okay, now let's look at the common framework. Yeah, common framework data. Sorry, I'm repeating myself. Okay, so what are the common benefits? We want to avoid catastrophic failure. We want to look at better space and inventory management, improve safety in terms of maintenance management, improve maintenance processes of critical assets, development of an expert system, information at fingertips, and reducing costs in the long run. Yeah. Okay, now let's look at this as a conclusion. Yeah? Okay, I've already taken 1 hour and 15 minutes. Okay, just nice. Then we leave the balance of the time for our discussion. I go back to the house. Yeah, why do I relate to the house? It's because of this. Building a 3-story house requires foundation. What is the foundation in this case? Is data. I emphasize on data. Without data, you cannot do anything. You don't have data. You can't even do a simple decision also. You just have to rely on either your planned maintenance or your breakdown maintenance or corrective maintenance. Yeah? Without data, you cannot do anything. You need data. That's your foundation. Now we look at the ground floor. You need the physical infrastructure. Once you have the data, you need to store it in a certain manner. Yeah, you need to have a physical infrastructure to store your data. Yeah, you need to plan how you want the data to be stored. Okay, first floor, domain expertise. You need your domain expertise to interpret the data, because whatever software you use in engineering analysis, you use, I mean, if you use any simulation software, you use any analysis software, there's a term called rubbish in, rubbish out. We are all familiar. So you need a domain expertise to help to interpret the data that you have collected, the data that you're going to process, and the data that is going to be reported and generated. Yeah. Second floor, data management, standalone or cloud. Yeah. How would you want to manage your data? Yeah. And lastly, once you have all that in place, then you can look into having CBM or AI tool. Yeah. Without this, without the first floor, without the ground floor, without your foundation, you cannot. You don't even think of looking at CBM. You cannot even think of looking at AI if you do not have your foundation and your structure in place. So without a strong foundation, the structure will collapse. For sure, it will collapse. Yeah? If you don't have any proper data collection procedure or process, then suddenly you want to do CBM, your structure will collapse for sure. You won't have enough data to make the sound judgment that you need. Yeah? So that is how that is my conclusion for today. So just a little bit on advertisement on one slider. Yeah, this is the company I work for, CBM. We have been doing it for 20 over years. Yeah, this is some of the certifications that we've got. Yeah, I would like to introduce Bumi Data Mining also as well. Just as a one slider. Yeah, they're a local company, collaborate with an Australian technology company. Yeah. And okay, so I'm open for Q&A and discussion. Yeah, please ask me. So I pass the floor to Mazia. You can contact me via email, or you can contact me via mobile. This is my WhatsApp number, so you can contact me. You can contact me anytime. Yeah? Okay, so thank you. I pass the floor back to Mazia. Okay.
Okay, thank you, Malik, for the wonderful talk. Okay, today I have read some question here from the question chat here. Firstly, is about parametric trending. Okay, question from engineer Wong Chu Huat. Okay, the question is about parametric trending analysis needs full understanding of production process factors that might have an effect on the actual trending data. Thus, human factor can be factored in analysis if he did not understand the actual production operational factors. How to avoid this human factor?
No, when we talk about parametric trending analysis, it's abstract. It then boils again to the data that you have, that you're able to collect. You know, I mean, that is why if you look at my conclusion, yeah, I talk about domain expertise. Yeah, you need to be able to be able to tell this data is important to which, you know. Okay, I'll give an example. If you're looking at RPM of an engine for the past 1 month, every day you're collecting, so you're able to produce the RPM at certain speed. Yeah, so you're looking at when you have limits. Yeah, that means your engine cannot go below this limit, cannot go higher than the above limit. So they say the ship is going at 20 knots, and this is the RPM of the engine, the range that it should be. Yeah, so you need, this is just a simple example. So you need a domain in whatever you do, you need a domain expertise to be able to translate the data that you can produce any graph. Excel can produce any graph also. You have the data, you store it, you know, but you need a domain expertise to be able to translate the data so that it be more significant. Yeah, I hope that answers the question. Mazia? Hello?
How to know, okay, second question is how to know the embedded sensors are giving incorrect signals for data collection. Also from engineer Wong Chu Huat.
How to know whether the embedded sensors are given correct information? I guess you have to counter check with manual, I suppose.
Correct.
Okay, that's one.
Correct.
Yeah, that's one. Then another one is from your historical information. Yeah, because you might, if you want to know your sensors is at fault, you rely on the historical performance of your sensors. Yeah, so you check, then suddenly you find one reading that is gone out of the way, that is spiked up or spiked down, doesn't make sense. So you go there, you manually check, either you manually check your temperature and you just want, or you can, or see, that is the beauty about this. When once you record your historical database, you will take effort to check your sensor, whether is it a sensor fault or is it really your bearing temperature is really going sky high. No, you know what I'm trying to say? You don't know whether is it a sensor fault until you check. And you know, unless of course, unless your sensor is connected to alarms and all that, that is a different story. It means you have an alarm in your control room, sensor goes up, then the triggers the alarm, that's a different story. But what if there's no alarm? Yeah, and you're monitoring that parameter. It's critical, but you're monitoring the parameter. So either you manually check it or you rely on your historical database and you actually check that sensor or that physical equipment. Is it a sensor fault or is it, or you can replace that sensor. Either you manually check the temperature or you replace the sensor to see whether is it giving the same reading or not, you know, or you check the equipment. You double check the equipment. Is it operating normally? So that is my answer. Yeah.
Okay, third question from Engineer Tan Kok Hee. Okay. Engineer, what industry sector commonly implements CBM? Comparatively, what sector uses AI monitoring? Thank you.
Okay, this is respectively, I won't be able to answer that per se. Yeah? Honestly, I won't be able to answer that accurately. Yeah, you can do a lot of reading in the internet. You will find most industries outside Malaysia actually implement some kind of CBM. Yeah, new equipment. Okay, in Malaysia also actually got, but it's very isolated. New equipment sometimes come with CBM. Like say you buy a aircon compressor, a huge aircon compressor. You want to cool down the whole ship. The compressor will be how big it is, and some manufacturers, some OEM does provide that technology. So to answer that question, military sector, yes, some worldwide military sector very, really monitor their equipment and performance very, how to say, very strictly, yeah, on CBM. On AI, I'm not really 100% sure. Outside of Malaysia, yes, there is a market that has been using it. Off and on, they use it for investigation. When they find a fault that they cannot use. And in Malaysia, I understand that one of the major oil producers are using it also as well. So it is actually a diversity of industry that is using it at the moment. Yeah, outside, very significantly outside of Malaysia, because it involves, you cannot have an everyday engineer do CBM. You need to have a dedicated person who actually sits down and look at data. Yeah, and he's the one that actually produces all the report, takes the data, collects the data, do the analysis, produce the report, show it to the engineer whether it is correct or does it need further investigation. So that is among the initial investment that an organization would have to do. Yeah, not mentioning looking after the hardware side of things and all that. So we are still, I believe Malaysia has still got a lot of potential because industries are realizing on the significance of strictly monitoring your assets. you spend a little bit, but in the long run, your ROI will be much, your savings will be much more. I think that will be my answer. Mazia, are you there?
Okay, yes. Next question from engineer Muhammad Tahi. What are the AI competencies required among marine engineers and seafarers to operate AI in CBM?
What are the competencies required? I don't know of any specific competency, but like I mentioned earlier, first of all is the mindset. Yeah, and second of all, you need to fulfill all the requirements that I mentioned in my three-story house just now. You need data. First of all, you need data. You need the physical infrastructure. You need the know-how. You need a person who knows how to manage data. You need a person who's able to interpret the data. And then, of course, it's basically software related. Yeah, but there's engineering knowledge behind it. So when you're talking about competency, will engineers be the best person to operate? Yes, if he's flexible enough, he's willing to learn how to manage a software environment. Yes, engineers will be the best because they have first-hand knowledge. Yeah, they have first-hand knowledge of what's happening. So one look at the data, they will know, oh, this is rubbish, or this is a sensor fault, or this something potentially is going to happen. You know, so but if you don't have that so far I don't know of any competency specific competency to use CBM and AI because of my exposure is just regular engineers and IT personnel, of course, using it. Yeah, so no specific competency. That'll be my answer.
Okay, next, what type of instrument for vibration data during taking measurement that apply in marine? Is that vibration or multi-channel analyzer? How you guys doing lubricating all sample during onboard? You have a facilities to do the analysis and testing on board. 3, for AI purpose, we need to install proximity probes on the equipment. Basically, we do AI to monitor high criticality equipment. This one from Mr. Ahmad Imran bin Qasim.
Okay, what kind of vibration instrument? I won't be able to answer that. Yeah, because I've not been exposed. But what data that you can collect that is significant to your operation? That's why we need to do a system audit. System audit, we have to sit with the operators. Yeah, before you implement CBM, you need to identify. So if you're talking about vibration, what kind of vibration data that you want, and are you capable of extracting the data? So if you want to use it for CBM, if you want to use it for AI, you must have the data. So what kind of vibration sensor? I wouldn't be able to answer that because different different operators will have a different parameters that they want to take. Yeah, and what is the next question, Mazia? Sorry, I can't remember.
Next question.
No,
next question. How you guys?
Yeah, the same question, but there's two parts of it.
How you guys doing lubricating or sampling during onboard? You have a facilities to do the analysis and testing on board.
Oh,
so number
topic. Do loop oil analysis on in situ on board? Yes, there are equipment that you can do. Yeah, provided by Canada and all that. I know of some equipment, oil analyzer where you can do in situ for initial investigation. Yeah, supposing you want to check metal debris, you want to check for some significant failure of your equipment. Yeah, through the loop oil analysis. Initially, yes, there are portable equipments that you can use. They are not cheap, but they are available in the market lah. That much I know lah. Yeah. Then once you find the initial root cause, if there is something wrong, then you can send for a further analysis for onshore. Yeah. So yeah, there are equipments that you can use.
Number 3, for AI purpose, we need to install proximity probe on the equipment. Basically, we do AI to monitor high criticality of equipment. His question.
Okay, I don't know about that. Okay, I can't answer that question because I really don't know about that. Yeah, because I work from the data collection onwards. Yeah, so the type of equipment that you use and all that, no, I'm not familiar with that. I'm sorry, I cannot answer that question. Yeah.
Okay, the next one. This one from Engineer Chen Yongqin. Is AI more superior than CBM, and will AI be the future trend going forward?
That is the question I portray back to you. If you remember my SYNOPSIS, I can't give you that answer because it varies. Operators varies from one operator to another operator. If you have the capability of gathering all the information in a centralized database, and you have methods of extracting the data, and you're looking into AI, then go ahead. You know, if you're more traditional, you just have sensors, and then you have log sheets, and you need human intervention. You need to do vibration. Then probably CBM is a more more useful tool for you compared to AI. Because AI, you need millions of data. Yeah, you need millions of data. You need millions of data for it to learn. You know, you just can't give a one-day history and then expect it to produce data. You won't do that. The software will fail. Yeah. So which is better for you, you would know better. So that's the idea of my talk, of my sharing of knowledge today. So I give the characteristics of the CBM, give characteristics of AI, and hopefully the final decision whether you want to implement CBM or AI goes back to you, because you are the expert in your organization. Which is better, I can't answer that. But for the future, I guess if you ask me personally, for the future, it will be correlated. You know, you'll be related. Some organization would be able to afford AI. Some organization or lesser organization may want to implement CBM. So, you know, if you ask me, the future will be a mix. You know, nothing will be superior yet. Yeah. So that's my personal opinion. Okay, Maja.
Okay. Next is, how can we marine industry to develop that competency?
Like I said, sorry.
This one from Muhammad Shafiq Muhammad Tahir. Yeah. How can we marine industry to develop the competencies?
No, basically there's no competency to develop. It's all in the mindset. You know, it's how flexible you are, your willingness to adapt to something new. Yeah? I never thought, you know, when I was a junior engineer holding spanner, I was just holding spanner and then the rag in my pocket. Never know that one day I will be talking about CBM. Yeah, and so there's no, and I'm an engineer by background throughout my career. Yeah, so I didn't go. I'm not a data scientist. I'm not a IT background, but it's just your willingness to learn as an engineer, to learn something new and to adapt it. Yeah. So, to my opinion, there's no specific competency that you need. You know, there's no specific competency that is required. Yeah, that's my opinion. Just a willingness to learn and adaptation to new things. Yeah.
More, Mr. Ahmad Imran Abdul Qasim say that, is that personnel doing CBM, especially in marine sector, certified by vibration analysis category 2 by Mobius Institute?
You see, this I think that's going too far already to get it certified and all that. This is your in-house operation to manage your own data. You're not getting it. You're not getting the system to be certified, and this is you managing the data in your operation so that you'll be making better judgment in your maintenance, everyday maintenance. So, if I get the question correctly, Namazia, yeah, he is talking about certification, is it? Hello, Mazia.
No,
Certification.
I'm not sure about. Yeah, certified vibration. Yeah. Institute.
Yeah, so we are talking about extracting data and managing data. So we are not talking about challenging the data that is produced by the equipment. No, we are extracting and we're just managing it. So talking about certification and all that, I think it's a bit far-fetched lah, to my opinion lah. Yeah.
Next is based on your experience on CBM, do you recommend wireless sensors or normal sensor with wires? Which will be the best so that external factor will not affect the signals? From Engineer Wong Chu Huat.
Oh, I see. Well, again, that's a very challenging question actually, because wireless sensors with wires has its challenges. Yeah. And I without going specifically to your place and seeing how your equipment is stored and all that, I wouldn't be able to make that decision like whether wireless equipment would better, because when you talk about wireless sensors, it picks up other signals as well. And then when you talk about installing sensor, that is another challenge. You know, how you want to install. I mean, if you're talking about engine room compartment, small compartment, where you want to install, how you want to install, where's the wire going to be, and all that, and that requires a design change. So that is a different challenge altogether. And I cannot answer your question. I'm not able to answer your question. Which is better? I guess it depends on situation. I have to analyze that particular situation before I can make judgment whether to use wireless or to use wired sensors. Yeah.
Okay, next is I mean from Tan Kok Hee. He asked about Engineer Malik, may I follow you with you directly on your involvement as coordinator on behalf of UK Engineering Council, such as membership application using EC Part 2 qualification plus our PEPC membership. Thank you very much. Maybe you can share your email address and he can communicate.
Yeah. Please email me. Yeah, I wouldn't. I mean, please email me lah. Please email me your request. Yeah. Okay. Anything else, Maria?
I mean, Engineer Malik email is written on the screen. Maybe you guys can contact. Yeah, he's through his and mobile phone number as well. Okay.
Yes. You can use company email.
There's no question. So I mean, yeah, that's all. Question from the rest is I already read all question. Okay. Anything you want to share, or maybe we can end our talk.
Yeah, I got nothing to share at the moment, so I can end. So with this, I thank you very much, everybody, for your time today. Time is just nice, 4:40. So I would like to thank you. This is my knowledge sharing. So if you have any opinions, this is a two-way learning session. So it's always, the technology is always evolving. So I'm also learning as well. And if you have any suggestions, ideas, and any information that you wish to share, please drop me an email and we can start the discussion. Okay, thank you very much, everybody, for your time. And thank you. I pass to you, Mazia. Thank you.
Okay, thank you, Engineer, for the interesting talk for today. I think we should end our. I hope also nothing to say. We should end our talk, and thank you for your participation for this evening talk and your registration. Okay, thank you, everybody. May pass to the IEM admin for this talk. Okay.